Hey everyone, Chang here and welcome to my channel. Today I'm going to talk about a topic that actually scares the living daylights out of me. Now, normally when we hear that, right, a topic that scares someone, it's probably a very difficult topic, one that we want to avoid at all costs, cross our fingers and hope it never shows up in an exam because we're probably screwed, right? That's not the case. Today I'm going to talk about percentage. Now, percentage is actually quite simple, right? Working with percentage. The thing that scares me is the fact that it is so simple, right? You use it every day. You use it in the grocery stores. You use it with coupons, with credit cards, in the news, in research, right? There's always percentage. And because it's simple and it's used everywhere, that it opens up room for mistakes, misinformation, misinterpretation, and just like, I guess, for malicious people to actually use it in a negative light. So, today I'm going to talk about percentage. Now, don't get me wrong. I love percentage. The good thing about percentage is that it takes very ambiguous or not so intuitive situations and basically really brings it down so you can actually grasp what's going on. Let's just say Bob earns $80,000 a year in IT. I don't know how much IT earns, but basically that much in IT, right? He gets a raise of $1,372. That's awesome. $1,372, I mean, you can buy a pretty good, decent computer, and it's every year, so it's just a good raise, right? But what if I say this? This raise compared to his salary is only about, I think it's about 1.7%, right? And what if I say this? That in IT, and of course I'm just completely making this up, in IT, let's just say normally people would get about a 3% raise, right? I guess to cover for living costs whatsoever, 3% raise. Well, all of a sudden this amount, which, I mean, if you think about it, oh, I can buy an awesome computer, a good TV, so on and so forth, it's actually not that great, right? It's maybe a little more than half of what, I wouldn't say should, but I mean what is average, what people normally would get a raise of. And just like that, even though this seems ambiguous, it might seem like a good thing, right? Putting it into percentage in this fashion actually highlights a bigger picture. It's like, oh, okay, I got a raise, great, but it's not comparable to other people. So maybe this kind of raise is not so good and he has to go and talk to his employer and, you know, negotiate a little more. But stuff like this is amazing when you use percentage, right? Now, that's why percentage is always used, because it would make problems like this a lot more simple. But then that means that we make complex problems that we need to understand every part of it too simplistic. It ends up becoming mistaken or misleading. So let me just show you several other problems, and we're going to talk about it. With this second scenario, I want to sort of highlight why percentage actually scares the crap out of me. So let's look at this. John produces a line of popcorn. In a test run, 50% of the people who ate it died. Now, of course, when we read something like that, or when we see something like that, it's like, oh my God, right? John needs to go to jail. We need to stop producing these popcorns as quickly as possible. Any that's already produced, we must get rid of it. 50% of the people died. But here's the thing. This is difficult because this could be a very complex problem that, because we decide to use percentage, oversimplified and changed our actual understanding. It might not be just what we think it is, right? 50% of the people died, half being dead, not great. But if I change it, if I add a little more information, let's just say, for example, maybe John is not the brightest character. When he ran his test run, right, he chose 2 people. So if we start looking at that, 2 people in a test run, and 50% of them died. That means 1 of 2 died. Okay? Now, that's bad, right? 1 of 2 died. I mean, we don't want anyone to die. But that's drastically different than what we immediately jumped. Our gut, conclusion is, right? 2 people in a test run, 1 of them died eating the popcorn. Maybe he just had shitty luck, right? He ate the popcorn, choked, or slipped, or whatsoever, and ended up dying. It might have nothing to do with the actual popcorn itself, but just 1 of 2 of them died. That's still 50%, right? But this is drastically different than if I say 10,000 people ate the popcorn and 5,000 people died, right? Then we have to really look at what the hell is in the popcorn that can kill 5,000 people. Well, that's what I mean, right? Just looking at the percentage itself, we jump to instinctive conclusion, but we don't get all the details. And because of percentage, we actually might not even question to see if we can get all the details, right? It could happen to be that if it looks like this and it's the detail itself actually shows it's not really all that bad, right? Maybe the popcorn isn't 100% safe, and then 1 out of 2 is just shitty luck, right? So hopefully this actually illustrates the potential negative of percentage. So how do we use percentage in a positive way and then avoid getting misinformed or mistaking percentage in a negative way? So let's talk about that. All right, so let's talk about actually what percentage is. Percentage or percent is basically a special type of ratio. Right? We went over ratio and proportion, how they're interrelated. I'm going to put a link in the description. But percent is a special type. It's one where the denominator is always 100, hence percent, right? Latin cent, 100. Now, there's a reason because I guess 100, it's easier for us to grasp. So what it normally is over 100, you put some number on top. Let's just say if I wanted 30%, let's just say 30% right here, right? 30 over 100, 30%. Normally, we would write this in either two other ways. We have the decimal form, 0.30 or 0.3, and then we also have the percent notation, which is going to be 30%, like that, right? And then we can do it with any number. If we wanted 45%, we just change 45. The 100 still stays the same. This would be 0.45, and this would be 45%. Now, normally, when you encounter percent problems, there's one of two things, right? You're relating two numbers and you're trying to find the percentage, right, in relation to those two numbers. Or you have one number and you want to find the percent of that number. So for example, let's just say I have 300 as my total number, right, total population or whatsoever, and I want to find 20% of it. So what you do is you would basically get your total population number. Let's just say total population. And you would multiply it by the decimal value of the percent. Decimal value of percent. So if I had 300 and I wanted to find 20% of it, my decimal value of the percent would be 20 over 100, which is going to be 0.20, right? So it's going to be 300 times 0.20, which would give us what? 60? This right here, 60, this number is going to be 20% of 300. So percentage is actually quite simple. Now, I wanted to show you this because there's the key. It's always in relation to total population, right? If you don't look at it in relation to total population, that's when you open up room for potential mistake, right? Think about our last problem. 50%, that's a big deal. But in relation to the total population of 2, not that big of a deal compared to if the total population was 10,000, right? So I'm going to go over different problems and I'm going to point out all the different total population, because as you break out problems into different segments, the total population actually changes. And if you don't take that into consideration, then you're going to make a mistake, right? So let's look at the first problem and let's see what happens. All right, let's look at this problem. Let's just say, for example, you have $300. I come up and I borrow 20% of it. Now, you're a good friend, hopefully, right? And you say, yes, of course, I'll let you borrow 20%. Tomorrow, I will definitely pay you back. So tomorrow, I paid you back 20% of what you have left over. We're good, right? I mean, you lent me 20%. I came back and I paid you back 20% of what you have left over. We are good to go, right? Sneaky, sneaky. No, you're not, right? I basically just cheated you if you accept it. No, big no. There's a reason, because there's actually two different scenarios that's going on right there. Originally, you have 300. That is your whole number, your total population or your total number right now. If you let me borrow 20%, right? Let's just find out what 20% is. It's going to be 300 times the decimal form of the percentage is going to be 0.20, which previously, if you realize, is 60. So you lent me $60. That means there's a different scenario, because what I paid you back in terms of 20% again now is what you have left over. So you don't have the original 300 anymore because you had 300. I borrowed 20%. I borrowed $60. So your next value is actually just 240, right? So if I paid you back 20%, again, they're both 20%, but if I paid you back 20% of what you have left over, basically it's going to be 240 times, again, 20%, right? 0.20. But I paid you back $48. That means, well, we can clearly see the difference, right? That means I get a gain of $12, you get a loss of $12, and you're not going to be very happy with me. All right, so let's look at this problem. Let's just say, for example, you are planning on buying a new computer, right? You go into the store and you see this. Oh my God, this is wonderful. It is 30% off the original price. I'm planning on buying a new computer anyway, 37% off the original price. Amazing. But now we have this sales associate or one of the store representative, right? They come up to you and be like, if you open up a member's card with us, you get 20% off the original price and an extra 20% off that. That's 40%, right? 20% off and then 20% off, that's 40. So that's amazing. Of course I'm going to open up a member's card, right? No, not necessarily the case, right? Keep in mind, once again, you got to break it down into different sections and truly understand what they're talking about. And sad to say, when you get into a situation like this, which is actually fairly common, maybe not buying the computer, but where it's like, oh, open up a member's card or open up this credit card, so on and so forth. Credit card, notorious for that. You actually have to truly understand what you're getting into. Now, let's just look at this scenario. You are buying a new computer. Assuming it's just a good standard computer, not the crazy gaming computer with the highest NVIDIA card or whatsoever. Let's just assume. Make up the price, right? Assume that the computer that you are buying is $1,000. Just to make our calculation a little easier, right? This will allow us to basically understand the situation a little better. Assuming original price, $1,000, now it's going to be 37% off the original price. So we have our 1,000, which is our total number at this point. We're going to multiply it by the percent just to find the percent, and then we're going to have to subtract it because remember, it is percent off. So the percent is 37%, right? And then after we multiply it, we basically get 370. So $370 off is what you're getting. 1,000 minus 370, let's just write it down here. 1,000 minus 370 is the actual price you're going to be paying for the computer, which is going to be what, 630? Cool. So that's just from that sale. In this case, let's just look at what happens if we open up a member's card. Now, once again, we're assuming $1,000, and we're going to get 20% off the original price first. Right? That's the mistake. It's not 40%. 20% off original price and then an extra 20% off that. So first we got to take 20% off the original price. 0.20 times 1,000, it's going to give us 200. All right, excellent. So original price, subtract the 20%, which is 200, right? So that's going to give us our next price. That's a different situation now. We have 800. Now we're going to get an extra 20% off that. 0.20, and we're going to multiply it. What is that? That's 160. So it's going to be 800 minus 160. Well, if it's 800 minus 160, what do we get? We get 640. All of a sudden, notice the difference, right? Without the membership, without having to go through all that, and most likely they'll charge a little, member fee or, whatever, right? The computer's going to cost you $630. But after all what it sounds good, right? It looks like intuitively it would make sense to be 40%, but it's not. It's 20% off original price and an extra 20% off, right? We realize that we end up actually paying more for the computer. $10 more, right? 640. And of course, now you have the hassle of the member's card and they're probably going to spam your mailbox and so on and so forth. But notice the difference, right? Intuitively, we would assume this would be a better deal. Actually, when we calculate it, it's not. So that's what you have to be very careful of with percentage. All All right, so at the risk of causing you to lose faith in humanity and just all of a sudden thinking everyone's out to get your money, here's the thing. Let's change the situation. Let's just say, for example, Jane has 60 whole candy bars. She gave 40% of it to her siblings. Of that left over, she gave 25% to her friend. With that left, she ate 35% of them. How many candy bars does she have left? Now, intuitively, if we just jump straight away and just look at the problem and think, oh my God, all right, so she gave 40%, then she gave 25%, then she ate 35%. Add them all together, that's 100%, so she has 0 candy bar left, right? Out of all 60, it's all gone. That's not the case. Once again, be very careful with percentage, right? Intuitively, that makes sense. Not so much. We have to look at every different scenario, every different situation. Originally, she has 60 candy bars. Cool. And then she gave away 40% of them. So, if we time 0.4, what do we get? That's going to be 24. She gave 24 away. Okay. Now, well, if that's the case, 60 minus 24, what do we have? What is that? 36? 36. Okay, cool. Now, with 36 left though, she gives 25% away. So, now, instead of the original 60, we have 36 candy bar left, and then we're going to find out what 25% is. 0.25. Right? So, if it's 0.25 times 36, what is that? 9? 9. So she gave 9 away to her friend. 36 minus 9 is what? 27. Okay, now after her friend, she ate 35% of not the original 60, not 36, but the new situation, 27. So 27 times, what is it? 0.35. And as amazing as it is that I would be able to calculate this very quickly, probably not. Let's do it. 27 times 35, or just 35. What is that? 5, 3, 1, 3, 0, 1, 2, 2, 8. And then you have 9, 4, 5 with the 2 decimal place. 9.7 or 9.45. Well, if that's the case, then you have 27 minus 9.45. What is that? 17.55. So, I mean, it's not a pretty number. She has basically 17 and a little more than half of a candy bar left, right? And so there it is, right? Originally, intuitively, all the percentage add up to 100, but because every single percentage applies to a different scenario technically, right? The first one when she has 60 candy bars, second one when she has 36 candy bar, and the last one when she has 27 candy bar. Actually, she does have quite a lot left over, 17.55 candy bars left. So, at the end of the video, there are several things I want to point out. 1, no, not everyone's out to get your money. There's a good number of people who are out to get your money. Not everyone. So don't lose faith in humanity just yet. The other thing is, hopefully you can see why percentage is actually very scary. It simplifies complex situation. But sometimes complex situation, you need to understand some of the details, some of the different scenario, right? Before we just jump to conclusion. It's so easy with percentage to just jump to conclusion because it's such a lovely and, I guess you say, small number, right? It's always out of 100, so we supposedly intuitively understand it. But that might not be the case. So always, when you see something like this, always question, what is the whole number the percentage is in comparison to, right? And this one hopefully illustrated. There was 3 different situations where the percentage is comparing a different set of numbers. So be very careful of that. But percentage is amazing. It helps us and always will help us. Is it scary? Yes, but that's just something we have to live with. Hopefully this video is helpful. Thank you for watching. See you in the next one.